This video introduces the concept of thermal energy storage technology, which is the technology used in heating, ventilation, and air conditioning, cooling applications. So, we would be covering the medium or the media which is used for thermal energy storage, and the technologies. Then we would be talking about how the thermal energy storage tank is sized and the materials which are used in this thermal energy storage technology. So, what is a thermal energy storage system? Uh, TES or thermal energy storage system essentially consists of some medium for storing the energy, that is a storage medium, then a tank for holding that medium, and then there has to be a chiller which would generate the refrigerating effect, and then there has to be a interconnecting piping system, chilled water piping systems, then pumps to make sure that the chilled water circulates, and appropriate controls. So all these are the components of thermal energy storage system. Now, what is the storage medium which is used in the thermal energy storage system? It could be either chill water, that is, you make sure that water is chilled in the refrigeration plant, and that chilled water, very low temperature water, is stored in the storage tank. So, in that case, the storage medium becomes chilled water. Or, what you could do is that you can use water and convert it into ice in your refrigeration system, and that ice is stored, and the ice would act as a storage medium. Could be also that you are using certain salts, eutectic salts, which would help in storing the energy. So, depending upon what storage medium we are using, whether it is ice, chilled water, eutectic salts, phase change material, that is going to decide the tank size, and that is also going to decide the HVAC configuration. In order to create the cooling effect, we obviously need a refrigeration system, right? Because the refrigeration system is going to create that cooling effect. And as I mentioned earlier, we need to have appropriate interconnecting pipes and pumps to make sure that there is a charging and discharging cycle. Now, note that thermal energy storage system is like a battery where you charge it and there is a discharge. So, a refrigeration system charges it, and when you are operating a air handling unit using the stored energy, that is a discharge cycle. Right now, we need to understand what is the capacity of storage. If you consider 1 liter of water, right, and if you want to calculate how much energy it can store, so now in this slide there is a small mistake. It has to be 4.2 kilojoules per kg. So a chilled water can store as much as 4.2 and not 2.3 as mentioned here, 4.2 kilojoules of energy every kg. So if you take 1 kg or 1 liter of chilled water, then it can store 4.2 kilojoules per degree centigrade. It means that if you have 1 kg or 1 liter of water, and if you have a delta T of 10 degree centigrade, allowable delta T of 10 degree centigrade, it means that that is going to store about 42 kilojoules of cooling effect per kg, and then depending upon that you can build up the tank of whatever capacity. So the temperature difference which I am talking about is the temperature difference between the stored water, the water which is going to be stored in the tank, and that of the returned water. So you understand now, if there is a sensible storage, the capacity is 4.2 kilojoules per kg per degree centigrade. If you are using a latent storage, that is phase change storage, by utilizing the freezing and melting phenomena of ice, then you know that 1 kg of ice, would absorb about 334 kilojoules of energy to when it becomes water. So that latent heat of fusion and latent heat of melting, right, that is utilized for deciding what capacity storage you have. Because if you want to store the cooling effect in the form of ice, so if you take 1 kg of water and when there is a charging, it will get converted to 1 kg of ice. So in that process, it is going to absorb 334 kilojoules of energy, or in other words, it is going to store 334 kilojoules of energy. So that is the latent storage capacity per kg of ice or per kg of water. Okay, so if you compare the two, the sensible storage and latent storage, so 1 kg of water, the storage is only 4.2 per degree centigrade, whereas 1 kg of ice, it is as much as 334. Okay, many times there is a, so latent storage is always desirable. Eutectic salts, you can use some salts or some phase change materials which can absorb the energy during phase transformation, right? And for example, if you take a solid eutectic salt, then it absorbs about 116 kilojoules when it melts, okay, when it becomes liquid, right? So eutectic salts as a phase change material are also used for storage. Okay, so the first important part of thermal energy storage is you have to have a appropriate storage media, and that is going to decide the volume of the storage tank. Okay, so the chill water stores 4.2 kilojoules per degree centigrade per kg. If it is ice water, then it is going to store 334 kilojoules of chilling effect per kg, and if it is eutectic salts, then about 120 kilojoules of energy could be, or cooling effect could be stored, right? Now, so obviously the storage density is maximum for ice systems and it is lowest for the chilled water system, and the storage density is medium for the eutectic salts. When you are talking about ice systems, they are too complex, whereas the simplest system would be the one with chilled water, right? Because the storage density is lowest, we need to have a very large storage tank when you are using a chilled water storage system, right? And if the space is limited, then we need to use some phase change material phenomena for storage. So space limited sites, we can use ice systems or phase change materials, and if there is a large projects where there is huge capacity of storage available or it can be built there, then we can use chilled water storage. Okay, so as I mentioned, chilled water storage is the most common on very large projects, typically over 5 lakh square feet, where there is ample space available. And what we do is that we use steel tanks or concrete tanks above the ground, or also sometimes beneath the ground, where we store the chilled water, right? In this case, thermal stratification is critical. So chilled water storage is attractive when the tank is very large, and we need to have a deeper tank, okay, above 20 feet. Okay, so this way chilled water storage can be planned by constructing huge tanks over or above the ground. As I already mentioned, that 4.2 kilojoules is the capacity per kg per degree centigrade, and if you are having an allowable delta T of 15 degree centigrade, that is, if you can store water at 4 degree centigrade and you can return it back at 18 degree centigrade or 19 degree centigrade, then typically delta T is 15 degree centigrade. It means per kg that water is going to store 63 kilojoules of energy, and hence if you want to build a chilled water tank which is going to store 1 ton of refrigeration, then that you can calculate as 12,600 kilojoules of energy has to be stored per ton hour of the water tank. It means if you want to store 1 TR for 1 hour, then basically the requirement is 12,600 kilojoules of energy has to be stored if you are using sensible capacity of the water, and then that will give you the capacity of the storage. Okay, so how do you calculate that? So that you will have to divide 12,000 kilojoules upon 63, and that gives you the storage capacity. Okay, we have learned in this video as to how do you calculate the chill water capacity. Now if it is a chill water thermal energy storage tank, what you would have is you would have a storage tank which is constructed, then you will have a chill water supply unit, and you have a chill water return unit, and you would decide on the temperature differential, allowable temperature differential, right? As I said, the allowable temperature differential is 10 to 20 degrees centigrade at least, but that gives you a huge sizing. If you want a small size, then we need to increase the temperature differential, but all this would be decided on the basis of application. We had one such unit in a central mall facility which is located in Nasik city of Maharashtra, where what they did was they built a thermal storage tank, okay, chill water storage tank, and they operated the system, thermal energy storage system, at night, made sure that the water was chilled, and the chill water was stored in the tank during the night, and in the afternoon, when the AC requirement was there, they shut down the refrigeration system and they simply operated the pumps and the air handling units and made sure that the mall was air conditioned in the afternoon. So the advantage is that we can make use of low cost electricity at night and offset some of our electricity bill by using a thermal energy storage system. So this is how the thermal energy storage systems find applications in your HVAC systems. Okay, as I mentioned, if you are using only chill water storage, you will require huge tanks. If you use phase change systems, then you can use ice storage systems, which are common on small commercial buildings where the space is limited, right? And it can produce lower temperature chill water, and hence we might require smaller pumps and pipings and coils for ice storage systems, right? We also mentioned about the phase change materials like eutectic salts. One such phase change material I am pointing out is inorganic salt, okay, wherein the freezing point is lowered to 8.3 degrees centigrade, and it gives you a high discharge temperature if your freezing point is 8.3. But the problem is, if the freezing point is 8.3, then eutectic salts may be used only in full storage operation, right? Because when you are having higher temperatures, your apparatus dew point is higher, and you cannot go for cooling and dehumidification. So that becomes the limitation of using the eutectic salt phase change material. You understand, no? Because if you are not achieving too lower temperature, that creates a constraint. So this way, when you are talking about thermal energy storage tank, we need to make sure that appropriate unit is used. Storage tank requirements, obviously from the structural point of view, they should be strong, they should be watertight and corrosion resistant, and obviously they need to be insulated properly, because we are talking about very low temperature storage to minimize the thermal losses. The tank materials which are used in thermal storages could be steel, could be concrete, or could be plastic, right? The details are provided on the slide. You can read those. What kind of materials are used in the given applications. This is a table which shows which type of storage which uses which type of material, right? So for eutectic salt systems, you'd see that concrete with polyurethane liner is used, because we are dealing with salts. For chilled water storage and ice harvesting systems, generally steel or concretes are preferable. Key factors in choosing a thermal energy storage systems is basically we need to make sure that the operating temperatures are proper. As I said, if the requirement is not dehumidification, you can use eutectic salts, but if you require cooling and dehumidification, then we had to use a chilled water storage or ice storage facility. If it's a small system, ice systems would do, but if it is a large system, that is, we need to use a chilled water system plant. That is what is called as economy of scale, right? We need to study the existing chiller equipment. We need to look for whether there is appropriate space available or not, and obviously ask the designer or owner what thermal energy storage technology is important for it. So this way, thermal energy storage systems are designed and installed in HVAC systems. Typically that would save your energy bill, okay, because it acts as a battery. Thank you.